Okay, glad to have you again. This is part 3 of Aqueous solution. So I need for you to pull out your chapter 4 packet, listen carefully, and then work out some problems with me. Same objectives. We will be able to predict whether a substance is a non-electrolyte, strong electrolyte, or weak electrolyte from its chemical behavior. Predict the ions formed by electrolytes when they dissociate or ionize. Identify substances as acids, bases, or salt. So your homework is a quest. Make sure you complete your quest for composition stoichiometry and reaction stoichiometry. Those who are not done with the summer assignment, do not let any deadline goes by because you won't be able to complete the work. We already discussed solute solvent, dissociation versus ionization. We talk about electrolytes and non-electrolytes. We ask you to review the main the rules for solubility. We talk about double displacement reaction, net ionic equations. We gave you a way to remember some of the polyatomic ions. This is another clue for subatomic ions. Let me talk about this one. Last time we did not discuss it. This is another way you can remember the polyatomic ions. Remember that line separates the metals from the non-metals. So we have the metalloids here. If I draw right here, we call it T41 or T43 rules. If I draw a T here, let's see if I can do a T. Is that a T? So everything inside that T, they will have 3 oxygen. Okay, you can put 3 oxygen here for all of them. BO3, CO3, NO3, and we have SiO3. And the charges are 3 minus, 2 minus, 1 minus. And since this is under the 2 minus, it is 2 minus. BO3, 3 minus, CO3, 2 minus, NO3, 1 minus. SiO3, 2 minus. And then we can form a 4. There is a 4 right here also. Right here. When we form that 4, all of those have 4 oxygen. Those polyatomic ions have 4 oxygens. And they are charges. -3, -2, -1. -2 since it is under 2, -2, minus, okay, -3, -1, -2, -1. This is -2. It is under the 2's. And then we have a 1 here, or you can form a 3. Can be a 1 or a 3. Those have 3 oxygen. And then the charges are -1, -1, -1, -1. ClO3 minus, BrO3 minus, I minus. So this is the T41 or T43 rules for the polyatomic ions. Next, we already solved this problem. Net ionic equation. We talk about neutralization reactions. One thing I did not mention in part 1, you need to know the strong acids and the strong bases. The strong acids are HCl, strong acid or strong electrolytes, because they will dissociate and they will ionize completely in water. Strong acid, HCl, HBr. Look at the periodic table. It is Hi, and then we have H2SO4, we have HNO3, and then we go back, we can this is HClO3, HClO4. Those are strong acids. They will ionize completely, therefore they are strong electrolytes. The strong bases are the hydroxide of the metals of group 1 and the heavy metals of group 2. LiOH, NaOH, KOH, or BOH, CSOH. CaOH2 is at the border, SrOH2, BaOH2. Let me repeat. The strong bases are the hydroxide of group 1 and the heavy metals of group 2. The hydroxide of the heavy metals of group 2. We ask you to take notes on that page. Reaction with water, and then we stop at oxidation and reduction, balancing oxidation reduction using half reactions. We gave you the steps, and that's where we stop right here. This was the last page for the notes for part 2. Let's see if we can solve this equation. You help me, please. Keep eyes on me, because I can make mistake. The first thing you need to do when they ask you to balance a redox, you need to assign oxidation number to each and every single element in that equation, so you will know which one had been oxidized, which one had been reduced, so you can split it into half reaction. H plus, this is 1 plus, and then this is H plus is 1 plus, so there is no change in your hydrogen. Chromium here, oxygen is 2 minus. There are 7 of them, give you times 7, give you 14. This is minus 14. You need the whole species to be minus 2. That means the 2 chromiums have to be plus 12. That means each chromium has to be plus 6. Each chromium is plus 6. Let's go here. That chromium is plus 3. Therefore, chromium is reduced. It went from plus 6 to plus 3. Let's go with here. Hydrogen is plus 1. Oxygen is minus 2. Hydrogen another plus 1 here. You need the whole thing to be 0. So this is plus 5. Plus 1 give you plus 6. Minus 2 give you plus 4. This is minus 4. Each carbon has to be minus 2. I hope you are keeping up with me in case I make any mistake. And then here my carbon is okay, oxygen is minus 2. There are 2 of them, give you minus 4. This is time 2 minus 4. That carbon has to be plus 4. And then the hydrogens and the oxygen, there is no change in oxidation number. So all I have to do is to split my equation into 2 halves. I said chromium went from plus 6 to plus 3. Chromium had been reduced. I do not pick up only chromium. I need to write the whole species. When we say species, is the way it is there in that solution. I do not just pull out the chromium from there. This is a polyatomic ion. So I write down Cr2O7 2 minus. I go straight in the middle of the page, leave a lot of space, and I write down Cr3 minus, 3 plus. So this is my red. This is my reduction half reaction. And then the other half is C2H5OH, leaving a lot of space, and I go to CO2. Okay, this is my ox. I don't even have to write the other species because nothing had happened to them. They will just come back. Okay, they will come back. So The first step is to balance the non-hydrogen, non-oxygen. Non-hydrogen, non-oxygen. I have 2 chromium here. I have 1 chromium. I put a 2 here. I have 2 carbon here. I have 1 carbon. I put a 2 here. Second, I'm going to balance all the oxygen with water. So I have 7 oxygen here. I need to add 7 water to balance the oxygen. And then I have 1 oxygen here, 4 oxygen here. So I need to add 3 water here. I'm done balancing oxygen. Now I'm going to balance the hydrogen by adding H+. Hydrogen by adding H+. I have 14 hydrogen here. I will add 14 H+ here. I have 5 plus 1 give me 6. Plus 6 in the 3 water give me 12 hydrogen. So I add 12 H+ here. Alright, now I'm going to balance the charges by adding electrons. Charges, electrons. Help me here. 2 minus 14 plus give me 12 plus on the left side here. 12 plus. This is 6 plus. So I need to add 6 electrons right here. Okay, keep up with me. I am human. I make mistake. I don't have any charge on the left side here, but I have 12 H+. I'm going to add 12 E- right here. The next step, I need the number of electrons gained to equal the number of electrons lost. Always. So what I'm going to do, I'm going to double the first equation by 2. So those 6 electrons will become 12. Because I have 12 electrons here. So I'm going to double the whole equation. Instead of spending the time by rewriting, why don't I put a 2 here? 2 here. This will be 28. This will be 4. This will be 14. Alright? Now, I should be able to cancel my, and then I need to double this also. Cancel my electrons. I have 12 electrons gained here. I have 12 electrons lost. I cancel them out, and then I rewrite my equations. So I have 2 Cr2O7 2 minus plus 28 hydrogen ion plus 1 C2H5OH. Okay, I already used this one. I use this one. I use this. And then let me see if I can reduce any water. I have 3 water here. I have 14 water here. So that means I have 11 water left here. Okay, let's see. And then product side, I have 4 Cr 3 minus 3 plus cannot read my handwriting. 11 water plus 11 water plus, okay, I already used the water here, 2 CO2 plus 12 H+, but I can reduce my H+. So this is 28 minus 12 give you 16. I can put 16 here. And CO2 already used, and that's it. We are done. You can double check. If anything is wrong, then you let me know. Let me move on with the video so we won't have to wait. Okay, next. This says, why don't you pause the video, write down this equation, and then you practice. You need a lot of practice. Remember, as AP students, you are college students, you need to be able to really respond to the independence we give you. I'm not going to pause it right now. You can pause it when you watch it because I need to move on. You need to do those practice. Like I said the other class, you will have to solve those equations again in electrochemistry. Okay, every time it says in an acidic solution, that means you need to end up with H plus in your balance equation. Acidic. So pause the video again, write this equation, and I'm sure some of them are in your packet already. So there's nothing after this. I don't think there's nothing. So you pause it, you write this equation, or double check your packet to make sure they are not already there. Acidic solution, you end up with H plus. Here's another practice here. Pause, check your packet. If you don't have it, write it down. I will move on. Okay, let me go back. Alright, 2 more steps for redox. 2 more steps. If the equation says it is in a basic solution, you should not end up with H plus. Alright, so for every single H plus you have the equation, you will have to add OH minus to both sides of the equations, not just the side where you have the H plus. You need to add OH minus to both sides of the equation. After you add the OH minus, you will be combining your H plus and OH minus to make water, and then you will be reducing if you have water on both sides. Let's do one example. This equation is in, let's say it is in a basic solution. Let me see if I have another one. Okay, let's do this one that is a little bit harder because I see oxygen here. I don't see any oxygen right here. So after this one, I will go back for you to come to pause the video for the other one. But let's solve this one because it says it is in a basic solution. We will follow the exact same rules. There is only one problem. I say, okay, let's start. Silver is a metal and it is not in a compound. So silver has its charge, which is +1. Silver is always +1. I'm sorry, it's not true. Silver is just an element here. It is not in a compound. It has to be 0. Okay, an element, if it by itself, you don't see any charge, the oxidation number is 0. But silver right here has to be +1. It is in a compound. This is not a compound. It is called a complex ion because you have a metal, you have an anion, and the whole thing has a charge. Usually, you will have a complex ion with a square bracket. It is not the square bracket for molarity, but this is just a way they usually express a complex ion. It is not a polyatomic ion. It is called a complex ion. Okay, silver went from 0 to +1. I already know silver is oxidized. It went up. Oxygen. I don't have oxygen on both sides. Since this equation happened in water, so I'm going to add water here. It's not going to affect anything because whenever you have solutions, you have ions, it's happening in water. So I can add water so I can use those oxygen to balance my equation. So let's see what happened. Oxygen here is an element. It is not in a compound. The oxidation number is 0. But in water, hydrogen is +1. There are 2 of them give me +2. And I know oxygen is always -2 except in peroxide. So oxygen went from 0 to -1. Oxygen is reduced. The oxidation number went down. Let's see what happened with Cn. This is Cn minus. The total has to be -1. -1. And let me see. And then my Cn here -1. I already know silver is oxidized. I know oxygen is reduced. So nothing happened to my cyanide. Nothing happened to it. Okay, this is this is minus 3. Okay, so this is just in the solution. There is no change in oxidation number. So I'm going to split. So I have Ag from 0 to +1, but this is in a species. I cannot split it. It's a complex ion. I cannot just take the Ag out of that complex. So I have to put the whole thing. This is AgCN2 minus. Even though nothing happened to the Cn, it is just there because of the Ag. And then I said the oxygen is reduced. This is my O2 and this is my water. So this is my red and this is my ox. So let's balance the non-hydrogen, non-oxygen. This is 1 silver here, 1 silver here. Let's balance the, let me put a Cn. Cn is just sitting there, but don't worry about it because I just have it there. It's not changing the oxidation number. So there is 1 Cn minus here, there is 1 Cn. There are 2 Cn, there are 2. So I have to put a 2 here then. And let's go with the oxygen. There is no oxygen on the first half. I have 2 oxygen here. I need to put a 2 in front of water. Let's go with hydrogen. There is no hydrogen in the first half. So I have 4 hydrogen here. I will put 4H plus here. Let's go with the charges. I have 2, 1 minus, 2 minus here. And I have 1 minus here. So I need to add 1 electron here. 1 electron. I have 4 plus here, 0 charge on this side. I need to add 4 electrons. And because I have 4 electrons and then 1 electrons, I need to multiply the first half by 4. So the number of electrons will be the same. So I multiply this by 4. Multiply this by 4, give me 8. And then I have 4 here. We multiply here and then 4 electrons. I can cancel out my electrons. 4 electrons. 4 electrons cancel out. Now let me rewrite my equations. I have 4H plus 4Ag plus 8Cn minus plus O2 plus 4H plus yield 4Ag Cn2 minus plus 2 water. Okay, I'm not done. The problem is they told me in a basic solution and I have hydrogen ion. Hydrogen ion means the solution is acidic. So I have 2 more steps. I need to add OH minus, enough OH minus to cancel out my H plus. So I need to add 4 OH minus, not just on one side of the equation, but in both sides. So I won't change that equation. Need to add 4 OH minus on both sides of the equation. Whenever you have H plus and OH minus, you combine them together to give you water. So I have 4 water plus 4 water here. And let me see if I have any. Now, and then I will reduce. I have 4 water on the left side. I have 2 water on the right side. I cancel those water and I reduce my water to 2. So this is your balance equation. 4Ag plus 8Cn minus plus O2 plus 2 water yield 4AgCN2 minus plus 4OH minus. So this shows it is in the basic solution because I end up with OH minus in our solution. Okay, let's move on. Any question, you can leave them for me or bring them for me. I'll be happy to answer your questions. So watch the video, go on video notes, the app on Google, and then put the video on that page. You can take your notes right there, write your questions, and bring them to class next time. Okay, here's another example. You can write this down. I'm not going to solve it because we are running out of time. So I really did not want to do a part 4, but it's look like that's what I will end up doing, because we took a lot of time in redox. So why don't you take some notes right now? Types of redox reaction. We have simple redox. Okay, one simple redox is hydrogen displacement. This is a metal right here. This is hydrogen here. If that metal is higher in the activity series than hydrogen, it will displace it. So this is a very simple single displacement reaction. Another one is, again, metal displacement. If zinc is more active than copper, it will displace it in this equation. So those are redox, because you start with zinc with a charge of 0, and then you end up with zinc with 2+. You start with copper 2+, you end up with copper 0 with an oxidation number of 0. So this is a redox, a simple redox. Alright, another one is a halogen displacement. If chlorine is more active, then bromine is going to displace it. This is again another simple single displacement reaction. Another one is combustion. Look at that O2. It is 0. The oxidation number of O2 is 0. O is 0 in O2, and it is 2 minus 2 in CO2. So oxygen had been reduced. Okay, and something else, carbon has been oxidized. Carbon went from -4 to +4. It is a redox reaction. I would strongly advise you to write down this word, because you may see it again. Write down disproportionation. Disproportionation reaction is a reaction in which the same element had been oxidized and reduced in the same equation. Disproportionation, this is where one substance both oxidizes and reduces. For example, chlorine here had been oxidized, chlorine had been also reduced. It went from 0 to, this is -2, total -1, so the chlorine has to be +1 here, and then here the chlorine is -1. So chlorine went from 0 to +1, it had been oxidized. Chlorine from 0 to -1, it had been reduced. Disproportionation reaction. And then the last example is reactions involving oxyanions such as dichromate. So the dichromate had been, the chromium had been reduced to Cr3+. So this is another redox. I think I went over my 15 minutes. What? Over? Okay, I went over the time. I will have to stop here, and I'm guessing there will be a part 4. Okay, so this is for the very first time I am having so many parts on one topic, one subject. So thank you very much for your patience, and I hope you really take the time and practice. Okay, enjoy the rest of your day.